So I'm Alex. I'm Alex Rass on pretty much everything: GitHub, Facebook, Twitter, LinkedIn. I am currently the VP of Engineering at a company called Freenome. Freenome is an AI genomics company that is working on an early-stage blood-based screen for colorectal cancer that uses a combination of next-generation gene sequencing and supervised machine learning to accomplish that. I also do consulting on the side as Bits on Disk LLC. Website for both of those things is there. So you might ask yourself, how does someone go down their career to the point where they want to give a talk about spreadsheets at velocity? So I started my career very heavily in the kind of whiz-bang analytics platforms part of the data space. I've been doing data engineering pretty much for the last 10 years, but I started building high-performance, large-scale data processing engines. In particular, while I was in graduate school, my co-authors and I wrote a thing called Triton Sort, which is a really efficient sorting system that set a number of world records in large-scale sort. After I graduated, I kind of pivoted slightly away from the whiz-bang rocket ship data analysis platforms and into something that would make those platforms easier for end users to use, in particular to use as part of their efforts to clean up their data and get it ready for analysis. And so I spent about 4 years as an engineer at a company called Trifacta. And then for the last 2 years, I kind of pivoted yet again slightly into more of an application-oriented portion of the data space at Freenome, where a large portion of my job has been to take Freenome's lab, which effectively takes tubes of blood and turns them into sequenced DNA, and then turns that sequenced DNA into feature vectors that are used to train machine learning models, and move that off of a collection of spreadsheets and into something that was more relationally structured and queryable and performant. So for the last about 5 years, I've been thinking a lot and also worrying a lot about spreadsheets, both as someone who was building tools for people who were trying to get a hold of and kind of control over their massive collection of heterogeneously structured data, most of which was in spreadsheet form, and also as a user of those tools in an environment where we inherited a large collection of spreadsheets that needed to be gotten control over. So in this talk, I'm going to be focusing kind of on distilling that experience out into kind of where I think the problem is and how we might go about solving it. I'll say just to start off, my focus on spreadsheets is going to be on the data aspect of the spreadsheet problem and not really focusing at all on spreadsheets as a means of computing, a means of kind of creating little ad hoc programs, which is one of the things that we'll talk about in a minute that spreadsheets are kind of good at and also kind of bad at. There is a researcher at Leiden University in the Netherlands whose name is Philiane Hermans. Her entire doctoral dissertation and a lot of subsequent work has been focusing particularly on the compute aspect of the problem. Her website, which is listed here, has links to a number of talks talking about that aspect, and I encourage you to go look at them because her work is super cool. So we're going to talk about this in 3 parts. In the first part, I'm going to try to convince you that spreadsheets are actually kind of great. They get a little bit of a bad rap among a lot of programmers, but they're actually pretty great. But in the second part, I'll then say that despite all those great things, they have serious problems, particularly as mechanisms for storing and transmitting and structuring data. And then finally, we'll talk about some ways that we can hopefully correct those problems, both on a case-by-case basis and perhaps more systemically. So first, let's talk about why it is that spreadsheets are actually pretty great. So you might argue that spreadsheets are the killer app of business computing. They effectively helped launch the personal computer revolution in the 1980s. They are arguably one of the most successful kinds of software ever devised. And they're everywhere. The world kind of runs on spreadsheets. And one question you might ask yourself is, well, why? I think that kind of comes down to 3 big categorical things. The first is that the spreadsheet is ubiquitous as a thing. So some numbers that will help illustrate this. In 2016, Microsoft released a stat that said that there were 1.2 billion users of Microsoft Office. And if you assume that the approximate population of the Earth in 2016 was about 7.6 billion people, that's like 16% of humans were customers of Office or users of Office. In addition, in that same kind of press release, they said that they had 60 million Office 365 customers. And I'm fairly sure, even though they didn't go into specifics, that those are 60 million businesses and not 60 million people, which is kind of brain-shattering as a number. And then finally, Google's in this race too, and their most recent stat that I could find said that more than 5 million businesses are users of Google Apps. And of course, Google Sheets, which is their Excel clone, is a part of that. So if you're not using spreadsheets every day, chances are the person to your right or left probably is. Second big thing, spreadsheets are really approachable to the kind of novice computer user. I'm using this as kind of like a really old example. This is one of the earliest screenshots of Excel that I could find, but the interface has remained largely unchanged. If you look at that, what do you have, right? You have a grid of cells. And anyone who is old enough to have read a map and has to use a coordinate system knows how to address those cells. They're rows or columns. You can look them up. How do you enter data into an Excel spreadsheet if you've never seen one before? Well, you might just click in a random place on the spreadsheet, and that highlights a cell. Then you might type some stuff and hit enter. And that stuff is now in the cell. And you can keep doing that pretty much as long as you want. Eventually, you've got a spreadsheet. You can save it, throw it in an email, send it to your friend. It's remarkably easy to use. And as a user experience, it's pretty smooth, which is why a lot of people reach for it first. Because if you want to structure a thing, it's a pretty good way to do it. Third big thing, spreadsheets are really, really flexible. You might almost argue too flexible. So the most obvious thing you can do with a spreadsheet is take numbers or sales figures or whatever else, put it in a grid. But you can also take that grid and embed a graph into the same spreadsheet, right? And as you update the numbers in the grid, the graph changes. That's pretty cool, right? Live updating graphs is a thing that, at least for the consumer web, we've only really known how to do well for 5 or 10 years. Also, because you have kind of positional locking that is a consequence of that data being laid out in grid form, pretty much anything that can go in a table can go in a spreadsheet. I mean, I'm sure everybody in this room has seen it used for project management and for things that you might want to lay out in like a better layout program, but you just reach for Excel and bold a couple of pieces of text and you're good. And then if you actually go all the way to knowing about, kind of not basic things, but like just above basic things like formulas and macros, you can actually rapidly prototype what you might call, if you squint, a full-scale app inside of a spreadsheet. And a lot of people do this just as a way to get some process off the ground really quickly. At Freenome, for instance, our entire kind of analytical process in the lab was, for a time, run off of a workbook that was effectively just put together so that all of the computations that needed to be done between stages of that process were just handled by formulas that worked between sheets in that book. And there are extreme examples of this flexibility. Here's one. There's a guy in Japan. His name, and I hope I'm not butchering the pronunciation too bad, is Tatsuo Horiuchi. And he's an artist, but his medium is kind of unique. That picture on the left was built in Excel. This is what it looks like if you actually open it up. It's really like a bunch of auto-shape shapes that are kind of anchored to positions in like 2D space by putting them up against cells. It's kind of incredible. And like his website's right there. He has hundreds of these things. And this is just one of those kind of extreme examples of how flexible this software has become. So I was going to, like, you remember that I was going to start to tell you about how spreadsheets are great and then say that they have problems. You go, well, look, if they're this ubiquitous, if they're this approachable, if they're this flexible, what's the problem? Like, this sounds like a slam dunk, like, go spreadsheets, go. Well, it turns out that there are a couple of problems, particularly when you start looking at spreadsheets as a way to store and structure and move around data. First big problem, data types. So I found a tweet a few months ago that I'll share with you now. I'll give you a minute to read it. How many people in this room have had some variant of this happen to them by show of hands? That's like a lot of you. So Excel and Google Sheets has the same problem, and so does Numbers. Like, they all operate under the assumption that they're dealing with business use cases, and that there are certain common business data types that the people that are working in these spreadsheets want them to be able to express and do kind of type-specific functions over. So if something looks kind of like a date, of course it's going to want to make it a date for you, because then you can extract the month, and you can extract the year or the quarter and all kinds of other stuff. Similarly with numbers and monetary values and all kinds of other stuff. But this automatic type conversion can cause some really serious problems. And there are examples of this across any one of a number of domains. Because I've spent the last couple of years in biotech, I'm going to focus on a couple of examples from biology. So this is the abbreviation for the gene that is called, poetically, deleted in esophageal cancer 1. So called because when you have esophageal cancer, that gene tends to be suppressed or removed. When you put that into Excel, what do you think happens? It says, December 1st, wonderful, right? You're never getting that old representation back again, no matter how hard you try. Here's another example. This is the identifier. Biology is great at just these huge alphanumeric identifiers for things. This is an identifier for a gene from a common house mouse. It's in a database called Riken that's managed out of a group in Japan. What do you think happens when you shove that into Excel? Well, you get 2.31 times 10 to the 13, right? Which is actually fine as long as you stay in Excel, because it keeps the original number and just does that as like a string conversion of the underlying type. Except if you export that spreadsheet as a CSV, it exports whatever it like displayed to you. And not only is that not what you wanted, but you've also lost information, because it's impossible for you to disambiguate between 2310009 and, let's say, 2310008, right? And this can cause a lot of headaches. And you might think, well, okay, this is probably just a couple of examples that people pulled out at random. It can't possibly be all that bad. Well, there were some people that did a study, and they looked at papers that had supplementary data that were published in places like Nature and Science, like journals so big that they have names named after concepts. And almost 20% of the articles they looked at exhibited this kind of problem. And who knows how much is there from the articles that didn't have their data attached. This is a huge, huge issue. Here's another thing that we've encountered at Freenome quite a bit. If I have a number that's 0000123, if it's an integer, it's equivalent to 00123 or 123. Notice that I didn't include 0123 because octal. But sometimes people will give you identifiers for things that are all numbers but are meant to be represented as like a 6-digit string of 0 through 9. And if you have multiple people that are giving you that with varying numbers of leading zeros, which has happened to me, you start getting false equivalence between things because your identifier space starts to collide with itself, and that's really not great. Another thing that tends to become a problem when you're in Excel land is enumerated types. So in any programming language you can name, you can define a thing that is an enum of allowable values, and it never allows you to do anything that isn't one of those enumerated values. You can kind of do that in Excel, but it's hard, so most of the time people don't do it, and instead they just type in strings. So I'll give you an example, and forgive me for all of the cancer-specific stuff. I hope it isn't too triggery to anyone in the room, but like I've spent a lot of my time in that space lately. Let's take, if you wanted to have a list of patients and what kind of cancer they're having, prostate cancer is one value. You could type it like that. You could also type it like that, or like that, or like that, or like that, or you could misspell it and type it like that, right? And in practice, when you have tens of thousands of these things in one workbook, you're going to spend a lot of your time just trying to unpack where the enumerated type even is, let alone making sure that everything conforms to that same value. So you can do things like elaborate schemes for sheet protection. You can do list validations that pull their lists from hidden sheets in a workbook and so on and so forth. Those things are relatively easy to stick in. The problem with a lot of those validations is that they're tied to the cell itself. And so if you happen to, let's say, paste over a cell, you lose the validation that was associated with that cell pre-pasting, which makes it really difficult to actually enforce that you're constrained by these types. It also makes them really easy to remove the constraints by accident. So hopefully by now I've convinced you, in case you weren't already convinced, that data types in Excel cause an enormous number of problems. But that's not all. Second big problem that you get when you're faced with spreadsheets is queryability. And you might say to me, well, Alex, inside my Excel workbook, things are amazing. I've got all kinds of material at my disposal. I have formulas. I can take my data and turn it into a pivot table and aggregate it every which way. I have filters. Basically anything I can do on a single table in a relational database, I can do inside of Excel. Your argument is invalid, right? And inside of a spreadsheet, that's true, but what if you're actually going to have to query data that sits across multiple spreadsheets, or really, in the extreme case, across multiple Excel workbooks? Well, as of Excel 2016, they imported a feature that used to be in Power BI, and they called it Get and Transform. I don't remember what it was called in Power BI. But you can effectively pull data from anything with an ODBC connection, but also from other Excel workbooks. And that's pretty cool. And Google Sheets has a thing called import range, which is kind of sort of equivalent, except its live reloading function is a little bit worse. Problem with Get and Transform, though, if you're using Excel on a Mac, too bad. But despite that, right, which is a relatively simple roadmap problem, this kind of falls victim to this, I pull in a snapshot of the data from someplace else, and then later, if that snapshot changes, I have to pull the changes in. So what if the structure of the table that you're pulling in changes? What if its physical position in the spreadsheet changes? What if someone decided to make all the columns rows and all the rows columns? What if a type changes? What if all of your formulas refer to a column by its name and someone changed the name? Well, you're going to have a bad time, right? You have to reload that data. You have to restructure it in a way that your stuff doesn't break. Then you have to go back and unbreak all the stuff that just broke. And because of this, people are really reluctant to do it. And in the course of researching this talk, I actually came across someone that said, you should have a contract with the person, an actual verbal contract with the person that has your destination data, that they will never change the schema for that data or move it around ever. And I'm like, yeah, that'd be a really good idea. Turns out you probably can't actually do that in practice. And then what about joins, right? Well, in joins, closest you've got in Excel, you have VLOOKUP. But then this is where my bias perhaps is showing, but that syntax is awful. And imagine if the position of that changes or anything else, it's bad. It's bad. And that's the state of the art, effectively. You can do index and match, but as a user experience, it's not much better. So in summary, data that sits inside of your spreadsheet is really, really hard to connect to data that's outside of your spreadsheet. So in summary, really, spreadsheets are bad at types, and they're hard to query. So how can we fix this? Well, everybody in this room should be jumping up and down. What about databases? Databases are good at this. And I'm going to focus in particular on relational databases for the purposes of this talk. Databases are great in a lot of ways that spreadsheets are decidedly not great. First, databases are great at defining and enforcing data types. I actually went through the Postgres manual. These are all the different types of types that there are in Postgres. That's a lot of types, right? And you don't just have the basics, you've got like geometric types and network address types and composite types and range types and pseudo types, and you can do JSON and XML. It's great. And it has native support for all of that stuff, and it will validate it for you. And if you try to insert something that isn't there, it'll just go, no. And that's pretty cool, right? Also, databases are purpose-built for queries and joins. That's like literally all they do. And so if you have a bunch of data that's sitting in databases and you want to kind of swirl it around in arbitrary ways, you can totally do that. You probably heard the but coming, right? But I will assert that spreadsheets aren't nearly as, or rather databases aren't nearly as approachable as spreadsheets are. Your options are effectively like visual tools. Shout out to anybody who ever had to use PHP MyAdmin back in the day. But like modern visual tools, better, but not that much better. Or you've got everybody's favorite, like just there's a prompt, type some SQL into it. And if anybody's tried to like teach SQL to someone who is trained as, you know, a molecular biologist, it's going to take a little while. It's not to say that those people aren't really smart, but they aren't trained for this stuff, and it takes a really long time. And if the alternative is I open a spreadsheet, I put stuff into a spreadsheet, spreadsheets will win 100% of the time. Furthermore, for better or worse, databases aren't nearly as flexible as spreadsheets are. I mean, databases can store data that's structured. They can query data in, you know, really fast and complicated ways. But that's pretty much all they do. If you want to do visualization on top of a database, you have to go find a tool and link that tool with your database. If you want to do more complicated stuff, you either have to find a tool or you have to build a tool to do those things. And that takes developers, and developers are expensive, and it takes a long time. So spreadsheets and databases both have things that they're good at, but they're good at very different things. And oftentimes the things that spreadsheets excel at, databases are pretty poor at, and vice versa. So I've given a lot of gloom showing how bad things are. What do we do about it, right? You know, the topic of this talk is how do you solve the spreadsheet problem, not what is it, right? So I can't give you a magic method that you can just like sprinkle on every database or every spreadsheet problem you're ever going to have, but I can give you a general pattern. That pattern is effectively, if you have data that sits in a spreadsheet that needs to go to a more structured place, there's kind of a distinct set of steps that you have to go through every time. You got to identify what use case your spreadsheet's trying to solve. You have to stop the spread of the spreadsheets, pun intended, by giving that data a structured place to live from a certain cut point forward. And then you have to fill all the data that you had in the past back into that more structured place. At the end of that, you should have a more structured place where that data can live, that your users will use. That's the hard part, it turns out. And that contains all the historical information that you could ever need. So let's talk about that first part first. Every spreadsheet, no matter how big or small, solves a business problem. Sometimes that business problem is small enough and ephemeral enough that you don't need to worry about it, and it will begin and end its life in a spreadsheet, and no one will notice. But sometimes it doesn't. Sometimes this is something that's part of the repeatable core of your business operations, and having that data stuck in spreadsheets is damaging you as a business in a serious way. But the first thing you have to understand is like that spreadsheet did not just pop into existence for no particular reason. It's there to solve a problem. So what is the problem? Like, what's the business need that's being satisfied here? Also, how big is the data that this spreadsheet is going to store going to get conceivably? Is it like 50K now, but it's going to be 50 gigabytes in 2 years? Or is it going to stay 50K forever? In some cases, you may just go, you know what? Fine in a spreadsheet and stop. But in other cases, you may want to go forward with what we're about to talk about. Also, how fast does the data in that spreadsheet change? If it's effectively read-only, then maybe you have someone who goes in and checks every once in a while up to a certain row where it's like, this is where I stopped checking, and you keep it in a spreadsheet and you move on with your life. If it's changing all the time, if there are 50 different people changing it all the time, your chances for screwing it up get higher and higher as your kind of user count goes up. I would argue that it goes up exponentially with the number of users. And then also, like, how frequently does new functionality need to be added to this thing? Is it really just a table? Or is it something a lot more complex, something with a lot of business logic in it that's going to be mutating fairly rapidly? So once you've identified this, if you decide that this is something that you go, okay, there's not enough logic here, or rather, it doesn't change fast enough that, like, let me back that up. It does change fast enough that you actually need to get it out of a spreadsheet, or it's going to get big enough that eventually querying it is going to be a problem, or it needs to integrate with some external thing that keeping it in a spreadsheet is going to be problematic for. The next thing you need to do is just stop the spreadsheet from getting any bigger, or rather, stop the number of spreadsheets from increasing, as the case may be. Best way to do that, give the new data a structured place to live. Luckily, there are a number of things that make it relatively easy to construct such a structured place. If any of you live in the Bay Area and have driven along 101 in the last year, you're probably familiar with Airtable. They've been advertising a whole lot. They have this kind of neat little product, this is not a paid endorsement, that effectively marries databases and spreadsheets together and for like a handful of really common use cases. So they'll give you a thing that looks a lot like a spreadsheet and feels a lot like a spreadsheet, but does type enforcement, that does joins, that will be queryable, that has an API. So they're one of the places that's endeavoring to kind of solve this problem. FileMaker has been around forever. They got acquired by Apple decades ago, and they're a nice little lightweight way of building this sort of thing that's backed by a database. There's a company called Ragic that will even import a spreadsheet for you and go, we think this is your schema based on the spreadsheet that you've just imported. Do you want to make a database-backed app that behaves like this? So there are a bunch of different solutions. Something that I wish that I would have told myself 2 years ago, resist the urge to build a custom app to replace your spreadsheet, at least at first. Here's why. Custom apps take a long time to build. Developers are expensive, time is scarce, and oftentimes your users have a rough idea of the kinds of kind of usage patterns that they're looking at, but they don't have a comprehensive view because they've only been using the spreadsheet version of this thing for a couple of months. If you can put them into an interface that behaves a lot like that spreadsheet and just watch how they use it and train them how to, actually, this is the key thing, train them how to use that custom thing to the point that they have as much fluency as they would have in spreadsheet land, and just watch, you'll either see a proliferation of like, well, God, I can't do this, so I have to throw it back out into Excel to do some piece of business logic that this thing doesn't support. And if that happens enough times, then you go, I have a set of requirements for an application now that I can go and build. But if that doesn't happen, you may be better off just taking that data and keeping it in, an Airtable or a FileMaker or something like that. So I caution you, because I should have done this, and it cost me a lot of time. The biggest thing in this phase is to optimize for speed, getting people comfortable with this new solution as quickly as you can, even if you can identify a handful of evangelists within your company who are willing to propagate that tool out to the larger group, is super duper crucial. Because until you get your user base off of making a bunch of ad hoc spreadsheets and into something that's a little bit easier for you to deal with and maintain, the problem will just keep perpetuating itself forever. Now, let's suppose that you've gotten to the point where all of the structured home has been built, the users have been trained, they're starting to put new data into it, or they're starting to use it for new iterations of their process. Now comes the fun part, the backfill. And this is something that I spent a while doing at Trifacta, at least building tools for. You're going to have to do some data wrangling. For those unfamiliar with the term, data wrangling describes the kind of broad task of taking data that is messy, by which I mean it's not structured in the way you want, or it's structured in a bunch of different ways, some of which are the way you want, or it's not structured at all. and transforming it and kind of shaping it into something that is structured enough that it can be ingested into that structured home that you just built for that data. And even though it's a little bit heretical for me to say this as a former Trifacta employee, sometimes writing one-off Python scripts is the best option for this. Like, if you know some pandas and you can get a CSV in there and make your data do what it needs to do with pandas in 5 minutes, don't spend an hour learning how to wrangle. Just do the thing in 5 minutes. If you want to democratize that process, though, and for sufficiently large data volumes or sufficiently large or sufficiently small development teams or both, you'll kind of have to do this. You need to kind of give people tools that will let them do some of that wrangling themselves, to let them help you. Because your team probably, number one, doesn't like doing this sort of work and will burn out relatively rapidly on doing it. Number two, for sufficiently large data volumes, you really can't do it yourself. So this is a shameless plug. The company I used to work for makes a tool called Wrangler. It was recently made part of Google Cloud Platform as Google Cloud Data Prep. There are a number of versions that are free to try. There's the website. The broad kind of thing that Wrangler does is it takes high-level actions like selecting stuff or brushing over a portion of a histogram or things like this, and it transforms that into a recipe that effectively takes your data from its initial form and transforms it step by step into a much more structured format. And a number of businesses across a bunch of different verticals have had a great deal of success with this. I'm more than happy to evangelize Wrangler's virtues after the talk. There's another option, though, that has come out of the research literature recently, and some of it has even found its way into Excel. And it's this broad idea of programming by example. The idea here is that rather than writing a transformation recipe that moves your data from what the input should look like to what you want or what the input is to what the output should look like, you just give it what the input is and what the output should look like and let it synthesize a program that moves from one to the other. So the first big example of this, and there are a number of tools that are similar to this coming out of the same research group at MSR, it's called FlashRelate. In FlashRelate, you actually just pick cells that comprise a row. So in this example, there's a red set of cells and a blue set of cells that represent rows. And FlashRelate will actually synthesize a layout transformation program that moves the cells around in such a way that the input becomes looking like what the output should look like. And the more examples you get, the better it does. I encourage you to look at some of the videos of this online. It looks like magic. But that's not the only thing. The thing about FlashRelate, though, is that the only thing that it knows how to do is layout transformations, taking cells and moving them around. It doesn't understand things like, for example, if I have data that's in one cell that should be split out into two separate columns, it doesn't know how to do that by itself. There's another piece of research out of University of Michigan, I believe it's pronounced FUFA, but I'm probably getting it wrong, where you actually just give it a sample of what the input is and a sample of what the output should look like. And not only will it synthesize the layout transformation, it will also synthesize syntactic transformations. So it'll infer regular expression parsers. It'll do all kinds of crazy crap like that for you. And they actually have, you can boot up their tool inside of a web server that is running in a Docker container in about 5 minutes. And they have a couple of examples, and the examples are pretty compelling. So in kind of summary, if you have a spreadsheet problem that you need to solve, first, you have to identify what the use case is, figure out whether or not it's even worth solving. Second, you got to give that data a structured home to live in and make sure that your users are trained and used to using that structured home for subsequent stuff. Then you got to backfill. And wish there were better solutions. This is the only one that I've found in years of dealing with this. Now, you might ask, well, what about the future, right? This sounds like a way to put a fire out. But if every time people go to software for data, they reach for spreadsheets, more fires will appear, and things will just spread, and I'll be fighting these sorts of fires for the rest of my career. So what are we doing about this systemically? And I can't offer a silver bullet, but based on what I've seen, I can offer some guidance. The first thing that I hope that I've convinced you of in this talk is that spreadsheets aren't really going to go anywhere, and they're not going to go anywhere for a number of really good reasons. Right? There are a number of compelling reasons for spreadsheets to exist. And so we can't just assume that one day we'll be able to convince everyone to just use a relational database from the get-go. Or can we? One thing that we can take away from this is saying, well, look, the spreadsheet is probably one of the most successful pieces of software ever built by humans. Look to why it's successful. Look at its ease of use. Look at its flexibility. Look at the simplicity of its interaction model. And say, what can we learn from that as we build new data systems, as we build new ways for people to interact with and create with data? How can we make the good parts of the spreadsheet follow along for that journey? How do we incorporate those positive aspects into the software that we're building now? But more importantly, what we have to do, I think, as an industry is to understand that sometimes, no matter how amazing the tools that we think we're building are, that sometimes users will go for what is comfortable, and that the shift from something that is comfortable to something that we want them to use will take a long, long time. And that really what we should be focusing on is not how do we build the most amazing tool that users will have no choice but to use, but really more on like, how do we meet these users where they are? How do we solve these problems in ways that are minimally disruptive to their normal flow of work? How do we make the stuff that we're building interface nicely with the spreadsheet in the hopes that someday we might gobble the spreadsheet's market share a little by little until all that's left is something better? And with that, I'm done. I'm happy to take any questions. Questions? Questions? Yes?
What would you suggest for a company that doesn't even have technical?
You know, honestly, like, that's a very good question. I think that the easiest thing, if you get stuff into like a product, I swear I'm not being paid by Airtable, but if you get stuff into something like Airtable, then at least if you need to develop the technical know-how or you need to bring in like consultants or contractors to provide that technical know-how, at least the data is in a place where it doesn't need to be extracted first. And like I would say, at the very least, get to that point. That would be my advice. Other questions? Okay, thanks very much.